Good news, everyone. Really is good news today. I think it's the first time I've ever said that, and it's actually good news. So, we don't have to prove triangles are congruent by proving side, side, side. All three sides are congruent. And angle, angle, angle. All three angles are congruent. We can actually tell that two triangles are congruent with a lot less information than that. Okay? In fact, half that much information. Okay? And it's a little complicated about what orders we have to worry about and everything like that, but we'll kind of do it a little bit at a time, so it shouldn't be such a big deal. So today we're going to talk about the side angle side congruence theorem. Now, there's a reason why we call it the side angle side congruence theorem, and not just because it says SAS. And it's one of my, it's not because we like that word. Notice how the A here is between the S's. Okay, that's very, very important. So when we look at two triangles, it's not just any two sides that have to be congruent and one angle. It has to be what we call the included angle. Okay, so let's say we've got a couple of triangles. And I'll draw one upside down just because I can. Okay? And let's say I tell you that these two sides, let me see how I rotated that. Those two sides are congruent. And these two sides are congruent. Okay? Now, in order to prove the side angle side congruence theorem, there's only one angle that's going to work here. Can you see which one it is? Can you see which one is the included angle? Okay, we've got to know that this angle right there and that angle right there, okay, we need to know that those two are congruent. And so that's how the side angle side congruence theorem works. I suppose we could kind of show you how this works a little bit. Like, for example, if I talk about, I've got a 10 centimeter one, and then I've got an angle that's, say, 30 degrees. And then I've got a side that's, say, 12 centimeters. How many different triangles can I come up with? I mean, if I draw a side here that's 10 centimeters, and then I measure an angle, I measure an angle that is 30 degrees, and then I draw a side that is 12 centimeters. So this is 30 degrees, and this is 10, and this is 12 centimeters. I end up with this particular triangle. Is there any other way to draw that triangle? What if I drew the 12 centimeter side first? Would that matter? You know, move that up a little bit. If I draw the 12 centimeter side, and then I put the 30 degree angle, let's put it up here this time. I gotta leave my glasses on, I'm getting old. Let's see, right here, and then I draw a 10 centimeter side. So this is 12, and this one's 10, and this is 30 degrees. Do I end up with a different triangle? A different shape or anything? No. I end up with a congruent triangle. Now it's a different triangle. I gotta say. They are different triangles. But are they congruent? And every single time, they're going to be congruent, aren't they? As long as, where's that A? Got to keep the A between the S's. It's got to be the included angle. You understand? Okay. So, is this a theorem or a postulate? In this book they call it a theorem. I'm not really sure. It might be more like a postulate, but we're going to go with theorem, okay? So this is the first theorem we're going to learn about in order to show that two triangles are in fact congruent. So you're going to be given problems like this. Given notice that's marked in the picture, right? Okay, and then also parallel to AD. Prove triangle ABC is congruent to triangle CDA. So you can see our two triangles here that we're trying to prove are congruent. Okay, so here's the good news, everyone. We don't have to prove that every side is congruent and every angle is congruent to make this happen. All we have to do is show side, angle, side. Keep that in mind. Side, angle, side. That's what we're trying to do. So we got to show that two sides are congruent and then an included angle. So let's think about what we have already. What do we have already, guys?
Two parallel lines separated.
Good. That's right. I was going with side. They gave us the side. Then we're going to go to the parallel line thing, okay? So let's do. You want a flow proof or do you want a two-line proof? Flow proof. BC is congruent to DA. That's given. And then also BC is parallel to AD. That's given. Okay, so we got this. That's our side. What is this parallel, two lines being parallel thing? Why are they telling us two lines are parallel? Yeah? So you got two parallel lines. Do we have a transversal? Okay, so we have got alternate interior angles, don't we? Okay. Now I want to ask a question here for a second. What do you guys think about this angle right here? I want to put an X on it, and that angle right there. Can we know that those two are congruent because of the parallel lines in the transversal? No, we can't. Now sometimes they might tell you that these two are parallel as well. And you know, if those two are parallel, like that, right? Now we got a transversal alternate interior angles that are congruent. But not the two that I have marked in blue, the two I have marked in red. So I think we can just say, let's see, what do we want to call them? BCA angle, I better do this in black, angle BCA is congruent to angle. Now if I call this one BCA, then this one's got to be DAC, doesn't it? Okay. DAC. So we want to name them in the correct order. And what's our reasoning again? Alternate interior angle theorem. This was given. This is given. Okay, now we got a side and we got an angle. Do we have another side? What other side do we have? AC. What about AC? It's congruent to itself. That's good, right? Okay, that's good. So we're going to say AC is congruent to AC. segment AC. So, what's that thing called when something's congruent to itself?
Reflexive.
There you go, reflexive. Reflexive property of, what are we talking about right here? Congruent segments, right? Congruent segments. Remember, there's a reflexive property of equality. There's a reflexive property of congruent segments. There's a reflexive property of congruent angles. There's the reflexive property of congruent triangles. Is a triangle congruent to itself? Sure. Okay. So now, look, we got another side. So I'm going to say triangle ABC is congruent to triangle CDA. And let's think of all the stuff that led us to this. Those two sides, right? These two angles and those two angles. And then didn't this parallel thing lead us to those two being congruent? Okay. And what's our reason? How do we know that those two triangles are congruent? Side, angle, side. That's correct. Look how easy that is, everyone. You don't seem convinced. It's not that bad. Hey, let's look at example 2 for a minute. I just want you to look at it and study it for a second while I draw it. Or something similar anyway. What can we conclude about triangle MRS, triangle misses, and triangle MPQ? What can we conclude about those two things? So now you've had a chance to look at it for a minute. Who says they're congruent? Awesome. Can you think of how we might prove it other than they look like it? What are you seeing, Creek?
They're in a circle, which is always perfectly round.
Right?
So it's I guess, I don't know, that's how I thought.
I think Creek just said all the radii of a circle are congruent.
Exactly.
Exactly. Yeah. Look, radius, 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 radius. What do we know about every radius of a circle? Yeah, they're all congruent, aren't they? Okay, sometimes we forget about that. We see a radius here and a radius here, and we forget that, yeah, all the radii of a single circle are going to be congruent. So we know that MS and MQ are congruent. We know that MP and MR are congruent, so I'll go ahead and mark all those because all the radii of a circle are congruent. So we got side and side. Now which one's the included angle? I see you all pointing at it, and someone said M. M, right? Okay, so we got to look at these two angles right here. Are they congruent? Yeah, all vertical angles are congruent, aren't they? So we've got side angle side.
Well, that would have been nice if nobody was today.
Okay, awesome. Let's look down at number 1 at the bottom of page 247. they want you to prove triangle SVR and triangle UVR are congruent. You're going to find that with these problems, it's super important to read the instructions at the top. If you don't read the instructions at the top, you're never going to get there. And I'll tell you a little story. Someone asked me a question in class a couple years ago, and it was similar to this one, and we started doing it, and I kept saying, okay, so how do we know this and this? And someone would say something, and I say, well, we don't have that. That's not something we talked about. It's not in the picture. You can't just assume that. And we got going, and we talked about it for like 20 minutes. And I kept waiting and waiting and waiting. And finally, there were tears, real tears rolling down people's faces in class. They were so frustrated. They're like, it has to be that way. It has to be that way. And finally, I can't remember what his name is, he raised his hand and he says, in the instructions above the problem, it says that these two things are this way. And then everyone burst out in tears of joy, and we finished the problem. So I guess the moral of that story is read the instructions, okay? It'll save us a lot of grief. So as you look at this picture, it says in the diagram ABCD is a square. Well, that's important. Can you guys see ABCD? So if it's a square, that means it's an equiangular, equilateral, quadrilateral. There's a lot of words, wasn't it? But it means a lot of stuff. It's not just nothing, is it? Okay? So we've got that, and then we've got these other things in here, and then we've got some triangles drawn in. And as we look at all these outside triangles, are they all right triangles? Yeah, they're all right triangles, aren't they? So a square with 4 congruent sides and 4 congruent angles. R, S, T, and U are the midpoints. R, S, T, and U are the midpoints of the square ABCD. Well, that's a big deal, isn't it? Yeah, I mean, if that's the midpoint, what does that tell us about CT and DT? They're congruent. Isn't that what midpoints do? Yeah, that's the definition of a midpoint. It divides the segment into 2 congruent pieces. And since AD and DC and CB and BA are all congruent in the first place, all these little pieces have to be congruent too, don't they? So look at all these outside triangles right here. Are they all congruent? How do we know? There's only one way you know. Side, angle, side. That's the only way you do know, isn't it? Okay? Okay, read the instructions. Copying a triangle. Let's take a look at the construction on page 248. Construct a triangle that is congruent to triangle ABC. All you need to know is the length of 2 sides and an included angle, don't you? Okay? So we can do that. You can do that with your compass. You see how they've done it. You can follow that through, but I'm just gonna draw a different triangle. Theirs looks almost like an isosceles or an equilateral triangle, doesn't it? I'm going to draw one that's not quite isosceles or equilateral, ABC, and then I'm going to copy it. Okay? So I'm going to copy it, and this isn't exactly construction because I am going to use the protractor. Construction means a straight edge and a compass, and we're not going to quite do that, but we are going to get close. So I want to copy AB. I want to make a segment that's the same length. So we'll call it point D. I'm going to come over here with my compass. See? And then if I put my compass here, any point along there can be point E, can't it? So I can put point E right there. And what do we know about DE and AB? They're congruent. Yeah, they're congruent. Okay? So these two are congruent. And then I want to copy this angle right here. Now, what do you guys think about copying in? Do you guys remember how to copy an angle? I guess this is actually going to be construction. Here, I'll do this in red so you can see what's going on. I just make an arc anywhere. And then I come over here to point D, and I make that same arc. You with me so far? Okay. And then, see these 2 points right here? We set our compass there, so we have that, right? And then I come over here, and I mark that same distance along the arc, like that. And then, when I draw this segment out here, oops, did I mess that up? I know that these two angles are now congruent. So all I got to do is figure out where along here to put point F. We can do that with a compass too, can't we? There's that distance. We'll copy it up here. There's point F. So now we've got side, angle, side. And if we can, if we just take F and E and put them together, what do you think? Congruent triangles? And how do we know? Side, angle, side. One more time. How do we know? Good. Do you think there might be other ways other than just side, angle, side in that order? Yeah. Little hint about what might be coming up. But it sure beats side, 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 angle, 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 doesn't it? Heck yeah. Okay. So here's our assignment for today. Chapter 5.3.